Today I'm going to share some of our pilot work looking at tracking of Rocky Mountain trumpeter swans, presumably greater Yellowstone trumpeter swans. So first, a little bit of context. A lot of this will tie into Dave Wilson's presentation from yesterday, but the Rocky Mountain population of trumpeter swans is estimated to be a little over 11,000 swans as of the 2015 survey. The vast majority of these swans winter in the greater Yellowstone tri-state area, so Idaho, Montana, Wyoming. And then most of them return to Canada in the spring to breed, and these are managed as the RMP Canada subpopulation. However, a small percentage, just under 5%, remain in the tri-state area for the summer, and these are managed as the RMP Greater Yellowstone subpopulation. So some things we know about Greater Yellowstone subpopulation. They're characterized by short annual migrations. And as you noticed in Dave's talk, we describe them in terms of core areas and expansion areas. So the core areas are those areas that encompass Red Rock Lakes, where we had a relict population, and surrounding areas where these swans are thought to have naturally recolonized. The expansion areas really focus on the south side of the core in this light gray. And my understanding is that this was a human-mediated translocation effort to really push that southern extent of their distribution and extend that north-south migratory corridor to give them more options if there's a harsh winter. These birds are counted annually during the fall, usually in September. So this graph probably looks familiar. This is the fall survey results from the Greater Yellowstone subpopulation as of 2021. We counted a total of 923 swans, and there's a very distinctive upward trend. When it's broken out by state, the Idaho block where I work is a little less optimistic. There's no discernible trend. However, what's a little confounding to me is this is some data from the breeding trumpeter swans in Idaho. The first graph is a compilation by Donnie Henry and Ruth Shea looking at the Idaho core. So statistically, it's declining both in terms of occupied territory and breeding pairs between 1993 and 2011. And then this is some of our unpublished data from our recent flights over the last 10 years. This includes nesting attempts at Camas, Bear Lake, and Grays Lake refuges, which in some years can account for 3/4 of documented nesting attempts in the state of Idaho. And I don't have enough here to be statistically significant, but you can notice that that downward trend does mimic what was seen by Henry and Shea. So as I'm struggling with how to reconcile this fall data that really kind of indicates a stable population with our reproductive data, we sought to get some more information about the spatial ecology of these birds. Specifically, we wanted to know more about adult GYE swan annual movements in terms of winter distribution, because this is a largely unmarked population. With all those Canada birds coming in and all the tundra swans coming in, you're not going to know when you see a GYE bird in the winter in Idaho. We also wanted to get a sense of summer site fidelity. Often when we did start marking birds, we'd see these breeding birds for a couple of years, and then they would disappear. And is that because they moved to a different site, or are they meeting their demise somewhere off of their summer grounds? And finally, we were interested in migration distance. Is this assumption that they are short migrants that spend most of their annual cycle in the GYE? Is that true? And then while we were doing all this, we wanted to start getting into winter habitat use. Are there threats that they face there that may be accounting for some of these population trends we're seeing and the lack of birds returning in the summer? So based on the premise that this was a population that didn't travel very far, we went with the economic version first, alphanumeric collars. We deployed, I think, 24 over 2 years across the 3 refuges, hoping that we could get some insight into these questions. And we were wrong. So this first graph, I can get the first graph shows the number of resites per bird over years since capture. And you notice that there weren't a whole lot of resites to begin with, but they definitely decreased over time. So we weren't really going to get any information on summer site fidelity. And then this next graph shows the proportion of those resites that were on refuge versus the teal color, which was off refuge. So that's not really going to help inform our understanding of where they're wintering. But it did give us some interesting insights. So on this map to the right, the brown and yellow stars are the deployment locations. The green or the gray shading is the GYE, and the green triangles are the resites that we did get. Notice that there's some at Great Salt Lake. There's one over toward Boise, and there's 2 up by the Canadian border. So with a region this big, alphanumeric collars really weren't going to answer our question. So this led to some methodological objectives. We needed a tracking technology that does not cause significant mortality, that maintains structural integrity in the face of North America's largest waterfowl species abusing it, and the GYE climate, which can, in extreme years, range almost 150 degrees Fahrenheit from winter low to summer high, and also deliver data over this larger area that we're now considering. So based on some feedback from people working in other populations and other types of birds, we went with the Ornatello Ornitrack GSM GPS collar. The way these work is they collect GPS points at a predefined interval. For us, we chose 1 to 2 hours. And they upload data using the 4G LTE coverage provided by 2 carriers in the United States, AT&T and T-Mobile. The coverage map is here on the right. You can see there's still a lot of white spots where there is no coverage in the West, so this is still very much a trial. The other thing we wanted was a tracker with some integrity that would get us multi-year data. So according to Ornatello, they estimated that these collars would transmit data for up to 3 years. These are some of our first swan ambassadors in 2019. This one on the right, I'm pretty sure was buzzing at us. It gets about 10 feet away from the boat and then just starts honking a lot. In terms of collars deployed, we deployed across 4 refuges that included both swans in the core and expansion areas. In the core, we deployed at Camas and Red Rock Lakes. In 2019, we collared a breeding female at each refuge. And in 2020, we added 2 additional collars to each refuge on presumed non-breeders. One of them was a second year, so we're pretty sure that bird was definitely a non-breeder. In terms of the expansion, we deployed a total of 4 collars at Grays Lake and Bear Lake. Grays Lake received 1 collar in 2019, and that was on a breeding female, whereas Bear Lake received a collar on a presumed non-breeding adult. And in 2020, we added an additional 2 collars on a presumed non-breeding adult, and then an unknown status adult that was in breeding territory that was active, but we never observed it with the brood. In terms of collar performance, this graph shows the number of days of data that we collected from that first cohort of 4 collars in 2019, and it was not inspiring. The first collar failed to connect entirely. It was deployed at Red Rock Lakes. We knew there wasn't coverage. We knew that bird had to move outside the valley to download. So it either never moved outside the valley, or the collar failed before it did. 2 collars failed the following spring, presumably as a result of the freeze-thaw cycle. We got 285 days of data off of that and 316 days of data off of that. And our best case scenario with the 29 collars, or 2019 collars, was the one collar that failed going into its second winter. We got 564 days of data off of that, all much lower than the 3 years we were hoping for. So I wanted to go back and adjusted the design a little bit to hopefully make it a little less susceptible to icing and ice damage. And in 2020, we deployed a total of those 6 collars. And I'm pleased to say that 5 out of those 6 collars are still transmitting today. That means we have over 800 days of data from 5 of these 6 birds, which is awesome. This also shows that we do have sufficient upload opportunities in most cases. There can be months at a time where these birds aren't uploading, but eventually they get close enough to coverage somewhere in their annual cycle where we do get access to this data. And perhaps most importantly, we haven't had any confirmed swan mortalities from deploying these collars. So what is this data telling us? The first thing I'll talk about is just general annual movements, and I've divided this by expansion birds and core birds, and you'll see why in a second. So all 4 of the birds that we colored in the expansion area spent their entire annual cycle in the GYE, as indicated by the blue track and the different shades of purple tracks. They also returned to their capture site in the spring, and in total, the distance between their summer and wintering habitats was 75 miles at the most for our most adventurous expansion bird, and for our most efficient bird, it was 20 miles. For the core birds, it's quite a different story. So 2 of the 5 did spend their entire annual cycle in the GYE. They returned to their capture location in the spring, but they did have a greater distance between their summer and winter areas. Instead of 70 miles being the maximum, that was the minimum, and the other bird traveled about 180 miles between summer and winter locations. However, what was really exciting to me was the 3 birds that spent subsequent summers in Canada. The bird that traveled the shortest distance was about 700 miles between wintering habitat and summering habitat, but the green track that you see almost up in the Northwest Territories traveled over 1,200 miles between wintering and summering habitat. This slide just shows the September locations subsetted out for these 3 birds, because if these birds are going up to Canada, are they truly part of the GYE? And here in the blue, in the GYE, you can see in 2020, they would have been counted as Greater Yellowstone core birds. However, in 2021 and 2022, all their locations in September were in Canada, as indicated by the orange and the magenta points. I don't have a little seismic plane where I can go see if they're nesting, but based on the concentration of points, it did not look like any of the birds up there have initiated nesting yet. In terms of winter distribution, we subsetted out the December, January, and February points from all collars. And what's really interesting here, I think, is that the warm colors indicate birds that were colored in the core area, whereas the cool colors, the blues, represent those that were colored in the expansion areas. And at least with this small sample, it doesn't look like they share very much in terms of their winter distribution. And it may be a figment of small sample size. I don't know. And finally, we just started looking at winter habitat use. So in the winter, trumpeter swans have been observed field feeding for the last couple decades, which is a novel behavior. So this is an example of 2021 data where we took the stationary points between January and April and November and December, and limited it to diurnal activity based on the sunrise and sunset at the winter solstice to see where these birds are on the ground hanging out. The tan bars represent agricultural areas. So not only are they using wetlands during the winter, but they are in alfalfa fields. They're in barley fields, corn, potato, wheat. They have quite the repertoire. We don't know if they're eating it, but they are stationary in these fields for a significant number of observations. Locations. So some conclusions. There are some very important limitations to consider with a 10-collar data set. This is a lot of intense data, but it's only for a small number of individuals. So we're not going to make any population level inference over this based on this data set. It's also a short-term data set. So we have about 3 years of data. So we can't really look at change over time. But what I think it does do is bring to light a whole bunch more questions. Does a distinct GYE subpopulation exist? I'm not saying it doesn't, but if it does, I think it might be in worse shape than our fall survey numbers are allowing. And that leads to the second question of what do the fall survey numbers in the GYE mean? It seems like, at least for 2020, 3 of those birds, if the pattern they are doing now continue, may end up being Canada birds. So what proportion of that fall number actually may lead to the breeding population here in the GYE tri-state? In terms of future needs, I would love to see more collars on more birds at different demographic stages. I think it's entirely reasonable that breeding birds and non-breeding birds behave differently. And I think more years of data will be really important in looking at the plasticity of individuals in terms of if one wetland dries up under climate change or regional water scenarios, do they move, do they just hang out and not breed, etc. This data set here, I think, is also being used in part or in whole in some other talks later this conference, and I'm excited to hear those perspectives. So with that, I'd like to thank our partners and ask the moderator if there's time for questions.